Imagine you're looking at a basketball sitting on a court. In our everyday world, that ball is right there, solid and stationary. But if that ball were a quantum particle, it would literally be everywhere in the stadium at once until the moment you looked at it.
Wait, so you're telling me things only decide where they are because I'm watching them? That sounds less like science and more like a magic trick or a glitch in the matrix.
It's the actual foundation of reality, Jordan. Today, we're diving into quantum physics, the branch of science that proves the universe is far weirder than our brains were ever evolved to understand. At the turn of the 20th century, physicists thought they had the universe pretty much figured out. They had Newton's laws for motion and Maxwell's equations for light, and they assumed they just needed to touch up a few minor details.
The classic famous last words of science. What was the detail that broke the whole system?
It started with something called the ultraviolet catastrophe. Scientists couldn't figure out why hot objects didn't emit infinite amounts of high energy radiation, which the math of the time suggested they should.
Infinite radiation sounds like a great way to melt the universe. Who stepped in to save us from the math?
A German physicist named Max Planck. In 1900, he made a desperate radical assumption. Energy isn't a smooth, continuous flow like water. Instead, it comes in tiny, discrete packets he called quanta.
Like how you can buy individual eggs, but you can't buy half an egg. Energy comes in prepackaged units.
Exactly. Planck thought this was just a mathematical trick to make the numbers work, but then Albert Einstein stepped in. He showed that light itself is made of these packets, which we now call photons. And suddenly, the door to the quantum world kicked wide open. Once physicists realized energy was chunky rather than smooth, things got chaotic. In the 1920s, a group of brilliant radicals like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger started building a new map of the subatomic world.
I know Schrödinger. He's the guy with the cat in the box that's both dead and alive, right? Please tell me there's a logical explanation for that.
There isn't one that satisfies our common sense. Schrödinger's cat was actually a critique. He was trying to show how absurd the Copenhagen interpretation was. That theory states that particles exist in a superposition, meaning they are in every possible state at the same time until someone measures them.
Okay, stop. How can a physical thing be in two places at once? If I'm not looking at my car, it doesn't suddenly smear across the entire parking lot.
In the quantum world, it does. Particles behave like waves of probability. It wasn't until Werner Heisenberg dropped his uncertainty principle that we understood why. You can know where a particle is or how fast it's going, but you can never, ever know both at the same time.
So the universe has a built-in speed limit on information. It's like the more you zoom in, the blurrier reality gets.
Precisely. And it gets weirder with quantum entanglement. Einstein famously called it spooky action at a distance. You can take two particles, link them together, and move them across the galaxy. If you change the state of one, the other changes instantly.
Instantly, like faster than the speed of light, Einstein must have hated that.
He hated it so much he spent the rest of his life trying to prove it was wrong. But every experiment we've done since then has proven that the quantum world really is that spooky.
This all sounds like a headache for philosophers. Does any of this actually affect my life, or is it just people in lab coats arguing about invisible dots?
You're using quantum physics right now to talk to me. We wouldn't have the transistor without our understanding of how electrons move in quantum states, which means no computers, no smartphones, and no internet.
So the glitchy math from 100 years ago is the reason I can use GPS and watch Netflix?
Absolutely. Lasers, MRI machines, and even the LED lights in your house rely on quantum mechanics. We are currently entering the era of quantum computing where we use that superposition we talked about to solve problems that would take a normal supercomputer millions of years to crack.
It's wild that we've built our entire modern civilization on top of a theory that the smartest people in history still don't fully understand.
Richard Feynman, one of the greatest quantum physicists ever, famously said, "If you think you understand quantum mechanics, you don't understand quantum mechanics."
All right, Alex, give it to me straight. What's the one thing I should remember when I'm staring at my coffee tomorrow morning and wondering if it's actually there?
Remember that at the smallest level, the universe isn't made of solid things, but of infinite possibilities that only snap into reality when you choose to look at them.
That's terrifying, but I'll take it. That's Wikipodia, every story on demand. Search your next topic at wikipedia.ai.